This is W2NDG, starting the OMARC Sunday Night Science and Technology Net. It's 8 p.m., which I believe translates to 0 hours UTC, or Zulu, which is the end of the CQ Sideband DX contest. And the bands have suddenly gone very quiet. But let's pause here to see if there's any emergency or priority traffic. Nothing heard. And once again, you are listening to the OMARC Sunday Night Science and Technology Net, held on the repeater of the Overlook Mountain Amateur Radio Club, 146.805 megahertz with a negative shift of 600 kilohertz and a PL tone of 103.5. If you would like to participate in the net, we'll ask for check-ins once we get through some discussions on tonight's topic. And you do not need to be a member to check in. You do need to have a valid amateur radio license, though. So we'll get to check-ins a little later. But let me discuss a little bit what we're going to be talking about tonight. Let me pause and see if Jim is around. K2BHM, my partner in crime, and I think he's really looking forward to tonight's topic as well. Jim, are you around?
I'm here. Thanks, Neil. K2BHM here. And should I break the ice or do you want to?
You can go ahead. You missed enough of these. And we're glad to have you back.
Okay, thanks. I got to admit, we're cheating tonight. We're cherry picking. It became obvious this morning. John JPT was on the 835 on the 805, and he was asking about the weather. The Fox hunt got canceled today or yesterday because of weather conditions and so forth and so on. And with all of our people now with weather stations and weather nets and stuff like that, why don't we have a better handle on things? And so it just kind of begs the question, what happens to all this data? We've all got these Accurate stations and we're getting all these kinds of measurements, and the Weather Service has these and satellites and radar and stuff like that, and all kinds of computer programs and documentation and all this data going out there. Where's it go? What's it do? What's going on with it? So I figured with Neil's background and experience, my background and experience, and you guys with your experience and so forth, let's pull our resources tonight and have some fun with it. See what's going on. See what we've got, and I'm sure we'll come up with a lot of answers and a lot of questions for some more Sunday Night Nets. Back to you, Neil, K2BHM.
And there's the repeater reminding us to announce our own call signs. I am W2NDG, Neil, in Highland. And we picked this topic. So what happens, and it's a great question. So we have these weather stations. A lot of us have at our homes. We did this, and Kenny kind of got us all interested in it when he started the weather nets last winter. And a bunch of us purchased these things, and I've been very happy with mine. So this thing sits out there in my backyard, and it collects data. Temperature, barometric pressure, precipitation, at least rain. I don't have a snow gauge on the thing. Wind speed, wind direction, not quite as accurate depending on where you have it mounted, but we're going to talk about how accuracy is not necessarily all that important when you're dealing with enough data. So, but all this information being, streamed somewhere, I mean, I can look at that information and I can tell you, what it is. In fact, because of the way I have mine set up, I can look at a web page and tell you what the current readings are. And looking at it, I know that it's 54 degrees in my backyard. And I know there's currently no wind, but I've been experiencing wind as high as 3 miles per hour. I know the current barometric pressure is 29.8 inches. I can even tell you whether it's an uptrend or a downtrend. Same thing with the temperature here. And I can tell you that we have had 8/100ths of an inch of rain today. All this information, humidity is 88%. I can tell you the dew point. But what does it all mean to me? I know that when I look at it, it means 54 degrees tells me if I go outside, I might want to have a light jacket on. It tells me that there's almost no rain and there's currently nothing accumulating, I don't have to worry about rain falling on my head if I go outside. Other than that, I'm not a meteorologist. I don't know how to interpret a lot of this. I know that if the barometric pressure is dropping steadily, that usually means that bad weather is coming. And the same thing if it's going the other way. Usually means that we're heading into high pressure, which we've learned usually means good weather. I got cut off there, but I said usually if the barometric pressure is uptrending, it usually means good weather is coming, as opposed to down, meaning bad weather is coming. These are the basics, and we've all learned this by, watching Dr. Frank Fields and all the other famous weathermen over the years. We know this, but we don't know the intricacies of it. Jim may know a little more than I do. I know Kenny knows more than we do because he's worked around it for so many years. But this information, so it's there. What happens with it, and what other information goes into us knowing what kind of weather there is? And I think we have to talk a little about the history of this. Let me drop. Weather forecasting is one of the most inaccurate sciences out there, and it has to do with the unpredictability and randomness of things dealing with Earth's atmosphere and how it reacts. As time has gone on, they have come up with more sophisticated models for predicting weather. But I think weather has also become a little more unpredictable at the same time. So sometimes it doesn't seem like we've gotten better, but I think in many cases we have. And sometimes the mistakes that you hear are simply our large media's inability to hold back sometimes and actually listen to the experts and report on what they're actually saying. Hurricane Sandy is a great example of that. Let me drop again. A lot of people backed off of the alarm because they pretty much were told that it wasn't going to hit Long Island as a hurricane. It basically hit dead center somewhere, I believe, just east of New York City. But you learn that certain meteorologists are better at interpreting things than others. I've always have been a big fan of Craig Allen, who does the WCBS AM weather and a number of other stations. And he was on the air saying, we need to take this seriously. This is a huge storm. It's the size of the storm and the amount of surge that it's kicked up and the fact that it's hitting at high tide. It was a perfect storm of events, if you pardon the pun. And he was right. And we remember the damage. We remember how much flooding it caused. And a lot of people just didn't take it seriously. So it's still going to happen. We can't always be right. But we're a lot better at it than we were. Early on, there were no computers. But there were a lot of other things missing from the puzzle. And really the only weather forecasting that people could do, and it was local because you really had no reliable way of communicating it out. You could if you were a genius at reading the clouds and the wind and the temperature, you might be able to come up with a forecast, but what were you going to do with it? You go up to the tower of your castle and shout it out. Forecasting was a local thing. So people were forecasting based on something called pattern recognition. And that's basically just recognizing certain sequences of events usually lead to other sequences. Not entirely accurate, but that's what they had. So there were other things in the mix. They would read the stars and certain things that really had nothing to do with it. But pattern recognition led to a phrase, a saying that a lot of people remember. Red sky at night, sailor's delight. Red sky in the morning, sailors take warning. And there is some truth to this. It didn't always work, but that's just an example of pattern recognition being used for weather forecasting. They got better at it. They started learning to read the clouds and even make records of the clouds, and then assign numbers to things like temperature and a wind speed scale. But the real kick, the thing that really changed everything, was the ability to communicate somewhere instantly. And hey, we're hams. We're all about communication. We get that. But this was telegraph. That was the original way of instantly communicating information from point A to point B. And, forecasts were useless before that. It's like, well, I've read the clouds. I've read the temperature. I know something's coming. I'm going to write it down on this piece of paper and give it to this guy on the horse, and he's going to run it over to the next town. So by the time you got, 100 miles, 200 miles, the weather's already happened and your news is old. But the telegraph allowed us to communicate that weather along those lines instantly and collect information from other places. Or tornado just hit 50 miles to the west. And we were told this on the telegraph, and it looked like it was heading east. So we're going to tell everybody to be careful and watch the horizon. And it was that instant communication that led to standardization of terms and numbers dealing with weather. Let me drop again. W2NDG on the OMARC Sunday Night Science and Technology Net. Continuing along, it was at this point that the people who were studying weather started to understand atmospheric physics, what the numbers all meant, what the observations all meant, and what they led to. And it was at this point that we started being able to produce forecasts that didn't always work, but they were certainly more accurate than reading the stars and checking your horoscope. This, once again, there's always milestones when you're dealing with technologies like this. It was the instant communications that led to this level of it. It was wireless communications that took it another step further. And the next major step in forecasting was the invention of the computer and the ability to use it for this. And that's when we get into something called weather models. This is how modern forecasting works. A weather model is a predictive program, and you plug the numbers into it and the observations into it, and it spits out a forecast. There are different programs for doing this. And what's interesting is that U.S. forecasting was using still a very old model that was written very well. And I'm going to tell a little funny story, and then I'm going to throw it over to Jim for a little bit, and then we'll go for check-ins. But let me tell my funny story. My middle son, Alec, who is waiting for his call sign and may be listening tonight. But Alec went to school for meteorology for quite a while. He ended up getting a bachelor's in computer science, but does have a bit of meteorology under his belt and really enjoyed it, but enjoyed computers more. And when we first went up to SUNY Oswego to tour the weather center there, and they really put on a show for him. It was really enjoyable. And the professors in the department, one of them met up with him and was showing us around everything. And I started discussing with him that I was a ham radio operator, and we were really into weather. And he said, "Oh, did you go to school for computers?" Because he knew I did that for a career. I said, "No, I did take a little bit of engineering, but really the only computer classes I had in my early days of college was a class on Fortran." And he stopped walking, dead in his tracks. And he looked at me and he said, "Do you still know it? Can you still code in Fortran?" And I thought it was a really strange question because it is a really old language. I said, no, I seriously doubt it. But, I have a logical mind, given the correct information and references, I could probably, reverse engineer something and figure out how it works. And that's when he told me that the weather model that we've been using all these years is still written in Fortran. Interesting stuff. And any of you people listening who know something about computers and computer languages are probably a little surprised at that, but you're also not surprised when you know that Fortran was a pretty high-level mathematical language as early in the computing age that it was. Modern computer weather models are written in much more sophisticated languages, and that's why some of the newer European models sometimes predict our weather a little better. But interesting stuff. But until now, we've talked about the information that comes out of our weather stations and the information that we see with our eyes and take pictures of with our cameras. There is other high-tech information that goes into forecasting. I'm going to throw it over to Jim, who can enlighten us on some of that. And then I think we'll take check-ins and start talking about some of this tech. So Jim, do you want to talk about some of the other technology we were hitting on?
Thanks, Neil. Well, you still got me laughing about Fortran. Sorry. When this stimulus package came out for the COVID, and they were going to give everybody the checks and so forth and so on, the main problem they had was that a lot of the computer systems were still using COBOL, which was one of the other mainstays back in the day. And they never upgraded. And NASA is desperate because they've got probes and stuff like that out there that are running in assembly language, and they need to do some updates and some revisions and stuff like that. And nobody does assembly anymore. So yeah, it's a common thread. Oh wow, bringing back memories. Anyhow, lots of different things going on. I did work for SUNY Albany, run a machine shop for 15 years. Been out of there almost 10 now. I work with a lot of the professors with atmospheric science research, setting up equipment and stuff like that for different observatories and remote logging stations and so forth. And we can go over a little bit of that and trace how things have changed over the years. Some of the stuff they were doing and how it's not necessary anymore. But I think we're going to have a lot of fun tonight. Back to you, Neil.
Well, thanks, Jim. And yeah, there's a lot that comes from places like where Jim used to work. And one of the things that we talk about, and this is when John was asking about it earlier today, the numbers that come off the weather stations are one thing, but a couple of the other things that they really need in order to understand what's going on are radar. And we're going to talk about that a little bit, and satellite imagery. And satellite imagery even comes in different forms, but radar, the type of radar, is directly related to RDF, radio direction finding. And it's an interesting topic, and it works similarly to one of the methods of radio direction finding. So Jim knows a lot more about radar than I do, and I'll have him do the heavy lifting there. But I think we'll take check-ins now, and then we can run through and see if anybody has any specific questions or comments so far. So let's do check-ins. Let me drop.
KC2 UVP, Mike Tivoli.
K9 JPT, John, Hopewell Junction, New York.
All right. I've got Mike UVP and John. I hadn't actually called for check-ins yet, but that's fine. I was just freeing up the repeater for a second. All right. So you guys are in first. And any other check-ins, please come now and check in with your call sign, your first name, and your location.
There is KB2, GGF, Matt in Kerhonkson. That's it. November 2, Foxtrot Zulu Charlie, Tom and Fishcombe.
All right. Oh, we have Jim, K2BHM, of course. Mike, KD2UVP. John, K9JPT. Matt, KB2GGF. And Tom, N2FCC. Anybody else like to check in tonight? Please come down.
This is KB2 RWW. Mobile on my way to work. Just check in only.
This is KD2VH, Jim.
All right. We have KB2 RWW and Jim, KD2VH. And all right. I think that's it for check-ins. So no specific questions on this first round. And then Jim and I will talk a little about radar, I believe. And Jim can talk to us about what he's observed in his days dealing with this stuff directly. But and first round, just any questions or comments you have on weather forecasting and data collection in general. I'm sure John has something to say since he's pretty much the one who started this. But let's start with Mike, KC2UVP. Go ahead, Mike.
Yeah, I was watching radar. I seen this one little blip of a red cell coming our way. I loaded up the truck with the girl and the dog, and we went out and we sat in that red cell. And I reevaluated my choice. Right after the red cell passed by, I went and played 18 holes of golf. And next on the docket for the cheese barrel, I've got a lacrosse technology weather station, model number WS2315CH on the auction block. Back to you.
All right, thanks, Mike. I'll have to look that one up. I wrote it down. We'll see what it is. But yeah, most of us have, I can't even think of the brand. Same company who makes the glucose monitors. But I have a mental block on that at the moment. But yeah, a lot of us got them all at the same time last year and had a number of technical problems because with all of the homebodies, people stuck at home, there's a huge influx of weather station purchases going on at the same time. All right. Thank you, Mike. John, K9JPT. How do you feel knowing that you're the catalyst for tonight's topic?
Well, it's very convincing that you take questions from the community very seriously, and appreciate you dedicating your time and attention to give more attention to this topic. For me, it's interesting, and it's interesting because I use APRS.FI a bit, and one of the most popular pinpoints that you see on their map are the weather stations. They seem to be everywhere, and then that got me to thinking that how is it that this event could have been canceled when all these weather stations are there and reporting the weather, and everything was clear and blue skies. So almost makes you wonder that the weather stations, why aren't they identified by their, because all it is it's the letters WX and a little, I guess it's a blue circle. That little circle should change based on the weather. If it's hot, it's red. If it's rainy, it's blue. But I'm looking forward to hearing more and getting a lot out of this conversation tonight. Back to net, K9JPT.
Right, John. And what I was going to say is, you've seen all the weather stations on the APRS map. And if you go to Weather Underground, they have a map that shows all of the reporting weather stations on their map as well. A lot of people don't realize they're there, but if you zoom in, that's when you start to see them. So, if you look at New Paltz, you'll see, from a distance where you're looking at most of the Hudson Valley, you'll see a circle with a temperature in it on the Weather Underground map. But if you zoom in, you'll see that more circles will appear. And all the way zoomed in, you'll see that there's one right here, right on my block, and that's my weather station. There's also one very close by, right up New Paltz Road. And I named mine with my ham call sign. So my weather station on the Weather Underground map is called W2NDG Elting Cors, CORS for corners. But the Weather Underground designation for my weather station is KNY HIGHL 31. So that's KNY Highland, I assume, is HIGL 31. So I'm guessing the 31st weather station that signed up in Highland, New York. I don't know if there's 31 of them on the air now, but I think they just issue the calls sequentially. But all that information, and you can pull some of it off that map just by clicking on those weather stations, may tell you current conditions, but it's not going to forecast. Let me try. And we could, someone could put together a very simple weather modeling program for the Hudson Valley for all the weather stations that we collect data from, and try to do some sort of forecasting. But that's exactly what the different weather reporting companies are doing. They're collecting all this data and producing a forecast out of it. But there's other elements that we don't have. I don't have a Doppler weather radar set up here. I don't have the ability to download and receive satellite imagery of my location instantly. And those are the other things that go into a proper forecast. So we can look at the map, and we can look at the temperatures, and we can even look at the radar map and see what's going through. But to really do what you're talking about, we pretty much have to write our own weather model or use one of the existing ones. So, but anyway, current conditions do help from moment to moment. But when you're looking at a day ahead and trying to plan something, then you are pretty much falling back on somebody else's forecast, because we really don't have the ability to create our own at the moment with our limited data. So anyway, it might be interesting if there are open source ways of computing this and somebody wants to look further into it. It would be kind of neat. But you really have to collect a lot of data to make it accurate, further out than we report from. Interesting stuff, though. And John, thanks again for bringing this up, because it's a great topic. Matt, KB2GGF, your thoughts on all this?
Well, my thoughts are rather novice about this. I haven't done a lot of research into weather stations or so forth. I've just been thinking that it might be an interesting thing to do. I was thinking of putting together a station either by buying one or making one, and I guess it's like ham radio, but with the weather. For that, it's an interesting thing to me, and questions I have are about communication. I know some of the weather stations connect into a net on the internet. They assemble the data and use it and so forth, but I'm really pretty much unfamiliar with it. So I'm just listening and picking up what I can, and any recommendations or suggestions will be accepted. Thank you. Back to net, KB2 GGF.
K2KRP, just checking in.
Kenny, excellent. Thank you. Welcome to the party here. I have you down. And it was Accurate was the company that I had the mental block on. And well, thanks, Matt. There are a couple of projects to create your own weather station using Raspberry Pi as the base computer. The thing is you still have to have the mechanical part of it. And it's still something you have to either purchase finished or create using a 3D printer and a machine shop, which can be done. There's actually plans for doing stuff like this. But yeah, you still, unless you have the ability to fabricate that part of it yourself, you're still going to be buying some of the components. But it is a fun project. There's a couple of them out there for making your own. Brad, who is watching on YouTube and commenting, was basically echoing what I had said, that when you're planning a large event that is very weather dependent, with a lot of people coming in, you're dealing more than 24 hours out in advance, and reading data currently isn't going to help you much unless you have everything you need to make a proper forecast. So, and that's what Weather on the Ground is there for. They're drawing off of our information. So I can look at that forecast, and I feel kind of good knowing that some little bit of my own information went into that. And we'll have Kenny talk about where our information has gone at some point when we get to him. Tom, N2FCC, you're up next on the OMARC Sunday night Science and Technology Net Weather Edition.
W2NDG and the group N2FCC. Interesting topic. I've had an interest in weather since early high school. And you talk about observations. I've been in the area here for like 50 years, and for as many years I've had access to radar and the internet and satellite imaging. I watch them the satellite animations, and I've seen clouds do this and this pattern on the satellite, and then you have experienced the rain. So over the years, I could sort of make a prediction, base it on the National Weather Service, and then I always tweak it with my own experience. Let's say they're talking, it's going to be 3 to 6 inches of snow, and I look at things and I'll go, it'll be more than 3, more the 3 side, and I got like 70% accuracy. So, but as far as forecasting, more than a couple days, the models, it's a tough thing to model all the variables. But I guess with the computers and more powerful computers as you go on, hopefully it would get better. But there's always that never can't fool Mother Nature. N2FCC back to that.
What were those commercials for? It's not nice to fool Mother Nature. I believe it was a margarine commercial. Jim, KD2VAH, you're up next. So, how's the weather in your basement?
Good. We had a bunch of Halloweeners, or whatever you call them. Little kids are adorable. And the nice thing about my neighborhood is the adults walk around with alcohol. Maybe that's how they tolerate the Halloween. Anyway, I went out and got the weather thing because Kenny was running the weather net, and I wanted to be part of it. I had no idea how any of it works. I mean, I put it up and everything, and like you said, I don't know, mine's got a forecast on it, says rain. Why does it say rain? As if we ain't had enough rain. It's got a thing that tells you how much light, how much UVI I have no idea why we need that. But anyway, so like I said, I just wanted to be part of the weather net. I mean, Kenny made it exciting. Back to net.
Thanks, Jim. And yeah, I have a lot of thanks to Kenny for kind of pushing me into something that I've always wanted to do, and understanding it a little better. But I'm pretty sure that he understands it a lot better than I do. So, Kenny, I'll just bring you up to date. We were talking kind of about the history of forecasting, and that early forecasters relied on pattern recognition. I mentioned red sky at night, red sky in the morning, that whole saying, and that instant communications changed everything. The telegraph, the ability for them to report weather instantly and collect data instantly, and then eventually wireless communications, and finally the computer and computer models. And I told a funny little story about my visit to my son's college when he was starting meteorology, and them lighting up when I told them that I had learned Fortran in college, because they were looking for Fortran people, because that's what the weather models were still written in. Interesting stuff. But we're going to get into a little discussion about Doppler radar and satellite imagery. But thanks for coming by, Kenny. I really appreciate you checking in tonight. And if you have any words on all this, you can talk to us now. So, Ken, K2KRP, come on.
Yeah, good evening, everyone. I just got back from Kennedy Airport, which is always a special drive. So I'm kind of just getting my act together here. I heard a lot of the earlier stuff you said, Neil. I love weather, and yes, I have been involved with weather since I got into the news business, which was in 1973. And most of the weather people every weather person you see on Channel 7, I hired. I even hired people that are now at the other stations. I love weather. I've studied meteorology, but because I could not stand physics, I kind of got out of it in terms of it becoming a major of mine. Let me drop. I am self-taught when it comes to understanding weather. I do read models. I'm very good at it, but I've had to study a lot on my own. And obviously, in working with meteorologists around the country, I learned an awful lot. When we came up here after the pandemic, and we moved up here permanently, and I kind of rejoined OMARC, I've always been such a fan of weather, and this is a very, very interesting area that we live in, between the ocean and the Hudson River and the Berkshires and the Catskills and the Adirondacks. All of those geographical locations all have a tremendous impact on the weather that we have here in the Hudson Valley. And John, JPT, when you mentioned the RDF and why was it canceled, the forecast for Saturday was going to be a miserable day with quite a bit of rain. The rain did come overnight, but we had a dry slot come in later in the morning. And for some people, it was sunny. I will tell you that it rained here in Marbletown most of the day. And in fact, driving home tonight, it was pouring for about 5 minutes in the Bronx, right near the GW Bridge. But everywhere else, the sky was beautiful and blue. Let me drop. So as Neil said at the beginning, this is a very inexact science and will always continue to be so. But with the advent of computer modeling, with the advent of brand new satellite systems and new radar systems, the idea of being able to predict weather has certainly gotten much better. But there will always be issues where somebody got it wrong.
And so that everybody understands the reason why different meteorologists, and if you watch a bunch of different TV stations or listen to radio stations, and the forecasts are a little different, in some cases a lot different, it's because how an individual meteorologist interprets the data. The same way that a doctor would look at an X-ray or look at an MRI and say that you have this issue or you need to do this. That's why people get second opinions with doctors, because they want to make sure that the diagnosis they've received is the best one possible. Meteorologists kind of do the same thing. They're looking at the data and they make a determination what that data is telling them, and they will make a forecast. When we did the WeatherNet, I looked at the models and I looked at the data and I know how to interpret it. I'm not a forecaster, but I can tell where something is coming and going and how much of it it's going to be. And then I make a prediction to myself, and if I'm comfortable putting it out over the radio, then I'll put it out over the radio. And that's how, that's why there's always differences. Let me drop. I won't call it Hurricane Sandy because it was not a hurricane. Everybody needs to understand, Sandy started out as a hurricane, but not when it came to the Northeast. When it came to the Northeast, it was classified as a superstorm, which is too bad for thousands of people, because the insurance companies never paid anybody for the damage that was caused, especially at the Jersey Shore, because superstorms were never classified in an insurance policy. And so a lot of people down there got really screwed and never were able to recover from the money. But what happened with Sandy is that Sandy was predicted to be a massive storm. What was not predicted is the storm literally came up toward New Jersey and New York City and made a sharp left turn. So it didn't keep going up the coast and go away. It got up to our area and then made a left turn and came inward. And what it did was it took all of the water in the ocean and literally pushed it like a plow right into the shoreline and right into the Verrazano Straits and right into New York City and Lower Manhattan. And with that pushing rain also came the wind. And that's what caused that incredible damage. So the storm itself was predicted, but the direction was not necessarily accurate. Let me drop one more time. Now, if you go back to 2000, I believe it was 2011, with Tropical Storm Irene, which devastated the Catskills. Tropical Storm Irene had gone inland and was coming through the Appalachians and then came right into our area. And what happened with Irene, which was not predicted, is Irene stalled. So the wind currents, or better known as the jet stream, was not in the right position for Irene. And when Irene came up into New York, it stalled. And it just sat there for more than a day and dumped 14 inches of rain in the span of several hours. And if you folks remember, Phoenicia, Margaretville, and Prattsville were wiped out, were totally wiped out. The Rondout Creek, the Esopus Creek, the Wallkill River totally overflowed its banks, took out homes, took out roads, and literally those three towns were destroyed. And that too was a storm that it was predicted to come up to the Northeast, but it was not predicted to stall. And that's what really hurt everyone up here, was that heavy, heavy, heavy rain. I will, get into, for those of you who are interested, what all this data that we get off of our weather stations really means. Just so everybody understands, Weather Underground is the Weather Channel. So if you folks are familiar with the Weather Channel, that is the Weather Underground. It is part of the Weather Channel, which, by the way, several years ago was purchased by IBM. So IBM actually owns the Weather Channel and Weather Underground. Weather Underground is hyper-local weather. That's why the Weather Underground was created, to kind of bridge the gap between, weather wannabes like all of us and the Weather Channel. So when a lot of these weather stations, because the Weather Underground is so big, these weather stations were set up so that you could hook into Weather Underground and provide them with data. One more drop. Now that data that is on Weather Underground is not used for weather forecasting. It is used for weather observations. So when Weather Underground passes this information on to the Weather Channel, they can basically see what a particular event is doing in a particular area. Kind of validates whether or not their information is correct or not, their forecast is correct or not. So when we take all of this data, when we have a weather net activation, and we collect all of this data, I send this data to the National Weather Service's Albany office, and they use that data to, number one, validate their forecast. Number two, they create storm reports that end up on the Severe Prediction Center's website so that people can see what, if any, damage or what, if any, flooding issues or snow totals or what have you. And I also send the information to all of the New York City television stations. If you notice Channel 4 and Channel 7 in particular, Kingston is now on their weather maps. And that is because we now connect to those TV stations. We send them all the data. When this last rainstorm happened earlier last week, all of that data went to the stations in New York, and they were using that data to show the rain totals. And we had some of the highest totals of that rain, and so they're able to tell that the storm had impacted the Catskills more so than, let's say, northern Westchester or northern New Jersey. So that data is used to basically provide storm reports and to kind of validate what their predictions have been all along. There's a lot more I can talk about, but I will throw it back to you, Neil, and if anybody has any questions, obviously, I'm here to try to answer them. This is K2KRP, back to W2NDG.
Kenny, thank you. Thank you very much. Excellent synopsis. And once again, thank you for pushing us in this direction. It's been a fun journey, and accurate description of Sandy. And that's what it was. People didn't know what it was, and it's not a hurricane. We don't need to be afraid of it. Yeah. And as I threw the comment out when you were talking into the chat room here, no one had superstorm insurance. Yes, correct. But it did change the way we look at things. It really did. So interesting stuff. Let's see if there's anybody else who wants to check in really quick. Anybody else out there who would like to join in? Please come with your call sign, your name, and your location.
Okay, N3UIQ, Paul Rosendale.
All right, thanks, Paul. And you're the last one on the list here, but do you have any comments or additions for anything you've heard so far?
Not really. I've been running weather observations up into, if you ever heard of Coco Ross. It's another system that they use to validate forecasts. I was NYUL1, so I guess I was the first one to get a number. Since I moved, they changed it to 31, but oh well, that's life in a big city. I've had a weather station now for about, it's probably going on 30 years now. I started out with a Davis weather station, and didn't really, I don't know, did I send it to the net? I might have sent it to the net. Either that or I put it out on PAG, and I forget which one it was, but that was a lot of fun. And of course, we always did the Skywarn nets here, and on the repeaters, and OMARC. OMARC's always been a pretty
good with the weather, and then all of a sudden we got this thing. Oh, we're not doing the morning weather net anymore. It's like, huh? All right, well, whatever. And but I still kept sending my daddy, and through CocoRoss and APRS. Figured they still need this stuff to validate what's going on and all that. And that's the whole idea of Skywarn and all that other stuff. Hopefully I'm not. Let me drop it for a minute. So we kind of been involved with it for years. So I met one of the. I've been up to the Albany Weather Service office. Been to the Harrisburg Weather Service office. I got to see the radar setups. Pre WSR 88 and post WSR 88. So it's like big difference in what they can figure out with the Doppler and what they used to be able to do with the old black and white radar. Back to that N3UIQ.
Neil, K2KRP, quick comment.
Sure, go ahead, Kenny.
Paul just made a good point. CocoRoss, which is, by the way, it's a very simple rain gauge. It's basically a plastic cylindrical tube. I have one. It's actually what the National Weather Service prefers for rain gauge when they want rain totals. The totals that I give them from our weather station here is from CocoRoss, which is basically a $22 plastic cylindrical collection that you hang out on your deck, and you can get it at Amazon. And then you join a CocoRoss network, which I could send the website to everyone. And they happen to like that because to them it's more accurate than these electronic rain gauges. Although I will tell you that my Accurite rain gauge and the CocoRoss are almost exactly the same numbers when we have a big rain. Maybe they're off by 1/100 of an inch, but it's very accurate. But Paul had a very good point there. And the other point, because he mentioned about weather spotters, anybody can be a weather spotter. You basically take this online course, and sometimes they do a live online course. They used to certify you with a number. They don't do that anymore, but they'll send you a certificate. And why weather spotters are so important, when you hear about a tornado warning, especially in our area, most of those warnings, they call them tornado warnings because they're Doppler indicated. And what Doppler indicated tornadoes mean is that the radar is showing rotation in the atmosphere. And when they see that rotation in the atmosphere, there is a potential for what they would call a supercell, which would be, in layman's terms, a very bad thunderstorm with very high cloud tops. And we're talking cloud tops 35, 40,000 feet. And so they will issue a tornado warning, but they never know that a tornado has touched down unless somebody sees it and then reports it, that there is a tornado on the ground. And that's why weather spotters or Skywarn spotters are so important, which is another reason why I created the current weather net, because this area does have some pretty heavy duty storms, especially the ones that come off the Berkshires, and they happen to head south, or literally the Route 28 corridor coming from the upper ends of the Catskills, again near Andes and Margaretville.
We had you up to Andes, Margaretville, and then you timed out. W2NDG.
Sorry about that. I apologize. So no, after the Andes Margaretville, what I was saying is the reason why weather spotting is so important is because that confirms very bad a very bad weather situation. Tornadoes. The Weather Service doesn't know that a tornado has touched down unless somebody sees it and tells them. The only thing the Weather Service can see is rotation in the atmosphere, which is why they will issue a tornado warning and call it Doppler indicated. So one of the reasons I set up the weather network is because this information that we gather, if we see real differences in temperatures or wind between our weather stations, it would indicate the passing of a warm front or a cold front. And if the differences in the readings are stark, then that could be indicative of a bad storm that is approaching. And so this information is very important and is very helpful, not only for the safety of the people that live up here, but also helpful to the Weather Service so that they could put out watches or warnings. Back to you, Neil.
Well, thanks again, Kenny. Cool stuff. So, all right. So we've talked about the data that we collect and what it's used for. We've talked about the basic data that goes into the forecasting that we look at. But what about some of the other stuff? Things that we don't do, things that we don't have the equipment for. And I wanted to talk with Jim about his experiences with seeing the back end of that firsthand. And then we want to talk a little about Doppler radar and how it actually works and how it ties into ham radio. But first, I want to make another radio connection real quick. I mentioned that instant communications was a huge milestone in weather forecasting, and wireless, again, another milestone. There used to be a lot more weather information available wirelessly. And let me explain that. Before we had the extensive satellite network we have for communications, and before the internet, HF radio was a major method of communicating information over large distances. Let me drop. There was a lot more data being sent on the shortwave bands than there is now. And when we were talking about the radio spectrum quite a while back, I mentioned that there's broadcast parts of the shortwave spectrum, and there's ham radio, amateur radio portions of the shortwave spectrum. Everything else, the spots in between, we refer to as utility. And there used to be a lot more of that as well, just in general. There still are ways of getting weather data through HF radio. There's a number of stations in the United States that still broadcast weather maps over what's called radio facsimile, which is exactly what it sounds like. It's a fax that goes over radio waves. It's a lot slower than that fax sitting in your office, but it works. And although pretty much the only thing you're ever going to get from a radio fax transmission these days is a weather map, they used to send press photos through it years ago. There is just regular data communications, digital communications in the form of radio teletype and other digital modes, some that we use in ham radio, that are sending weather information. And that is of use to marine craft that can't receive that weather through other methods. It still exists as a backup method for a lot of people, and it still works. So I thought I would mention that. But what about everything else? How are the weather companies getting this radar? How do they know that there's a storm 70 miles to the southwest moving at 40 miles an hour and dropping hail on Monticello, New York? How do they know that? How are they able to collect that type of data from a distance? And I want to talk to Jim about that. Jim, K2BHM. What are your observations from working with some of this stuff? And then we can talk about Doppler radar a little.
Okay, Neil. Jim, KWBHM here. Before we get into that, let's get back into a little history. Back when I was a kid, there was a guy by the name of Ray Falconer. He was a meteorologist for Atmospheric Science Research Center at SUNY Albany, and he did a lot of the observations and formulating the weather broadcasts or weather forecasts that you would hear on the radio broadcasts and TV broadcasts. And he was a radio amateur, and he would, on 2 meters, give the forecast over 2 meters on his way to work in the morning. And he would remark about how what he was predicting and what the media was saying sometimes didn't quite agree. But anyhow, and the standard joke back then, and still is, you don't like the weather here? Wait a minute, it'll change. And it is notoriously a very difficult area to predict here because of all the mountains. We've got the Catskills, we've got the Green Mountains, we've got the Adirondacks, we've got the Hudson Valley. There's a lot of turbulence going on and a lot of unknown factors that can influence things and change it. If you're out in the Midwest where everything's flat, down Texas or whatever, you can see the weather coming for 3 days. It's no big deal. But here, it's very challenging. So let me drop a second and we'll start and get into some of the advances over the years. So, okay. Yeah, years ago we had radiosondes. You'd take this little transmitter and connect it on a balloon and send it up in the air, and it would take temperature and humidity and barometric pressures and telespot it back down to receivers, and you would see what's going on at different altitudes and stuff like that. And we still actually do that. Yeah, we do get a lot of airplane information from all the flights overhead and so forth, but they do still send up weather balloons with radiosondes to get particular information pertinent to something. And back when I started at SUNY, back in '98, one of our major customers was Atmospheric Science Research Center. Again, Ray Falconer's old areas of employment, and I made a lot of different mounts and adapters and all kinds of different things, interfaces and stuff like that for atmospheric science to set up instrumentation. They have the weather observatory on the summit of Mount Snow, and then I would make other stuff for their other observatories, and they had projects where they would go down to South America and all around the states and so forth, and send information back, and they would process it here with their computers. Let me drop again. So back 20 some odd years ago, they had quite a network of sensing stations. As a matter of fact, I still have one here. If you go across the little bridge over the Esopus on Glasgow Turnpike off of 9W, you'll see a little station there. It's tied in with telephone lines, and it still reports levels to the Esopus back to atmospheric science, and they do still have some of those, but the equipment that they used was very expensive and calibrated and scientific grade, and they still have several of them around, but really they have gone to using us. Everything's on the internet now. We go out and we buy our weather station and put it on the net, and they have free access to it. And yes, it's not as accurate as their equipment would be, but it's good enough for them to see a snapshot of what's actually going on and correct their software. Yeah, they've still got their important stations here and there that are to scientific standards, but they have us to fill in the gaps and correct their data, correct their approximations. So we do serve a vital role. We help basically fine-tune the system and improve it as it goes along. Let me drop again. So anyhow, we've got that tool. We've got the observations from the official scientific calibrated sites. We've got our data from our sites. They've populated satellites over the years. Satellites are looking down on the Earth and mapping things out, both with visual and infrared. And just as a little sideline, when you pop your cell phone out and take a picture, or you take your digital camera and take a picture, that sensor, that CCD array in there that's taking the picture, is infrared sensitive. And there is a filter over it to filter out the IR so it doesn't distort the visual image of what you're taking. So your picture of Aunt Sally isn't polluted by her running a temperature. And if you're playing around with Raspberry Pis, you'll notice that Raspberry Pis have cameras, and they have the no IR camera. The no IR camera does not have that IR filter on it, so it is sensitive to infrared as well as visual. And you'll notice that during the day, when everything is hot, the picture will be really washed out, and you don't really see what's going on. But they have both modes on the satellites, taking pictures and sending it back down to computers that are tying everything all together and stitching it into one big picture of the whole globe. So that is another major influence on weather predictions. Let me drop again. Neil, are we ready to get into radar?
Sure thing. Sure thing. And you can probably give us a little more evolution on it than I can.
Yeah, well, there was this guy way back by the name of Hertz. Did some experimentation in AC, and we actually changed the name to honor him. And he did a lot of the groundwork that eventually wound up and recognized and realized that radio signals existed, and that certain things would bounce them back, reflect them, if you will. And so people started doing experimentation with this back in the late 30s, the last half of the 30s. They actually started doing radar, radio distance and ranging, and it initially was for the purpose of tracking ships so that they didn't collide in the fog. But it goes all the way back to the late 30s. Wow. And they were working on about 6 megahertz, which basically was state of the art back then. That was really way out frequencies. And they wound up eventually later on refining it and making it a much more useful thing due to the war coming on and needing to track ships, aircraft, and so forth for protection. And that's when they started getting into the polar style cathode ray tubes, where you would see the sweep that was going around in a circle and indicating blips on there as to what was out there, ship-wise or plane-wise or whatever. Let me drop again. So interesting. So what actually is radar? Well, you transmit a quick pulse of a signal at high power, and it goes out and it reflects off of something and bounces back. And then you pick up that signal on a receiver. And the further away that object is that it bounced off of, the longer the delay between the pulse from the transmitter and the echo received on the receiver. And those early CRTs and the electronics behind it would sweep around in sync with a rotating antenna and paint a picture with a CRT that had a long persistence, so that once it put a spot on there, it kind of stayed for a while and glowed, so that you could see it and keep track of it and see how it updated when the next sweep came through. So it kind of gave you a little memory of what was there and then an update on the next rotation, which kind of was an important innovation back then. Just let me drop again. So yeah, things progressed, and they started playing with different frequencies and noticed that different frequencies had different resolutions. And as we know, 6 megahertz, the length of the wave is fairly long, and so that means the resolution is kind of lousy. But as you get higher in frequency, you get different propagation patterns, you get different resolutions, and a lot of things change. And so they played with this over the years. And then they started to notice that, when it gets cloudy out and it starts raining, we don't see the aircraft anymore. What's going on here? And then they started figuring out that clouds and rain produce images back just as well as an airplane or a ship. And so now research went on with that. And be dropping in a second. So probably one of the landmark serendipity situations was the engineer from Raytheon that was on board a ship and went up to fix a radar and forgot to turn it off, and noticed that chocolate bar in his pocket melted. Of course, he was cooking himself as well, but he didn't know that back then. But that led to some more experimentation, and found out that basically the water couplet, the hydrogen and oxygen, H2O, 120-degree included angle in the bond structure, that thing has a resonant frequency. And that resonant frequency turns out to be somewhere around 2.54 gigahertz. So if you put out a signal at 2.54 gigahertz, you hit the resonant frequency of the water couplet, you get a big return. And as a matter of fact, that is the theory behind and the reason why you now have a microwave oven. That magnetron puts 1,000 watts at 2.54 gigs, which happens to be the resonant frequency of the water couplet, and it heats your food up and your coffee and whatever else you stick in there. So let me drop again. So there's been a lot of research over the years with different frequencies, which gives them different ranges, different resolutions, different patterns, whatever. And as things developed, originally it was a rotating antenna that you sent out a pulse from the transmitter and then look for the echo back from the receiver, and then the antenna would progress a little bit and you'd send out another pulse and look at it. And that's why you see on the radar, on the TVs, this sweeping beam. That's basically the way things worked back then. And now Neil was talking a while ago about the fox hunts, where you have multiple antennas and you switch between them to discern between different signals coming from the or different paths, signal paths coming to the receiver from a single transmitter, and from there you can determine the direction and potentially distance as well if your computer is strong enough, powerful enough, and got the right software. Well, that's all valid for radar too. They set up multiple antennas, switching them through pin diodes into the receiver, and now with the advent of software-defined radio, you can have a radio for every antenna, and you can have an antenna every 10 degrees around the circle, and let the computer analyze the data and paint a picture from that. So let me drop here and see if Neil has any comments before I continue on.
No, it's a pretty good intro and getting to where, because you'll hear them refer to it sometimes when you're watching the weather on TV, or Doppler radar forecast, and that's what it is. But computers and computing power have given us the ability to look so much further into things and do all of that heavy math and get the information we need. And that's what allowed them to make these software-defined radio-based radar systems. And the software is very sophisticated, and the processing is very sophisticated and gets better and better. Basically, now, for at least the RDF part of it, if you run one of these systems and just drive around for half an hour, it'll produce a whole heat map. If you plug a laptop into it and basically show you where what you're looking for is. And a lot of these systems work best when you're in motion. It's just the nature of the physics behind it, that to get that proper Doppler reading, one party needs to be moving, at least. So either the detector or the detected in motion helps things. When we're doing RDF in our cars, using devices like this, we're the ones moving. It works best when you're in motion. But when they're doing something like Doppler weather, it's the weather that's in motion. And we could talk about radar and get into things, probably get an engineer who works with it today and talk about crazy things like over the horizon radar and things like that. But for the purposes of weather, Doppler definitely makes sense. And although, like Jim's saying, it definitely started in a much more primitive fashion. It's all pretty cool. And it's that ability to see things in motion and know how dense they are, how fast they're moving, how tall they are. That's what gets them the ability to really, really get forecasts down and get the warnings out when something bad's coming. Back to you, Jim.
One comment.
Go ahead, Kenny.
Yeah, first of all, thank you so much, Jim. I'm quite frankly learning an awful lot about the technical aspect of radar, and it's fascinating. So thank you very much for that. Just to let the folks on here know there's a very basic difference between the weather radars that are used now. Now, not everybody has Doppler, and there are some TV stations in this country. NBC in particular, when I started working in Boston a few years ago, invested millions of dollars in developing their own Doppler radar system for the NBC-owned television stations, including a Doppler on a mini flatbed truck. We called it Stormwatch. And basically, you hook this on the back of our Jeep, and you literally, or in this case, a truck, and you literally could travel with this Doppler radar to an area where the weather was going to be really bad. But there's a very basic difference between regular weather radar and Doppler. Regular weather radar simply provides information about the location and intensity of precipitation. So if it's light green, it's light rain. If it's dark green, it's a heavier rain. If it starts to turn orange, then you're into a very moderate, more moderate rain. Red is a sign of a very heavy rain or potential thunderstorm. Doppler radar adds the capability to look at air motions within a storm. And that's why Doppler radar is such a key to predicting the most severe weather, which would include, straight line winds, hail, and obviously supercell thunderstorms and tornadoes. So those are the two basic radar differences. I mean, Jim can certainly get into the science of it all, but from a general user standpoint, Doppler adds air motions to the radar, and regular radar is the location and intensity of precipitation. Airlines have to use Doppler because that's what determines whether or not they're about to fly into very turbulent air. So the airlines and airplanes all use Doppler systems so that they know what they're flying into as it relates to wind. And so those are the two basic things. Jim, again, thank you for all that science stuff because I'm learning an awful lot. Back to you.
Thanks, Kenny. Yep, I was just going to get into Doppler. As you know, as you are sitting there at the crossing, as the railroad engine is approaching you, blowing his horn, the horn pitch is high, and then as he passes you, the pitch goes down, and that's called the Doppler shift. And we see this on radar as well. When the cop was sitting on the side of the road with the radar gun out there, he was transmitting a 10 gigahertz signal bouncing off of you coming back, and his equipment was analyzing. And for every mile an hour you were coming towards him, the frequency of the reflected signal would go up 31.4 hertz. And that particular ratio is for 10 gigs. As you go up in frequency, it goes up. As you go down in frequency, it goes down. So that is frequency and speed dependent. And so they use that in radar too. They know from what particular frequency they're transmitting on, what their resolution is, what their range is, what the speed is, and they can determine an awful lot from the Doppler shift. And now we get into a little more technology. There's polarization. We know that when we talk on FM, we normally have a vertically polarized antenna, and when we talk on HF bands, we normally have horizontally polarized. Well, that is pertinent too in radar. Let me drop a second. Okay, let's imagine for a minute. We have rain coming out of the clouds and falling down. And that rain is falling through the atmosphere. And the atmosphere is exerting some physical conditions on it. Resistance due to friction and air currents and so forth. And those droplets start off nice and round, but they tend to flatten out like pancakes. And the amount that they flatten out depends on the size of their quantity of water contained in each particular droplet. So if you've got fine rain, a drizzle, it pretty much stays round. But if you have a heavy rain where there's large droplets, it starts coming out like a pancake. Now, what's that do to us? Okay, if it's flat like a pancake, it is going to give you a much larger reflection on a horizontally polarized beam than it would on a vertically polarized beam. So now by sending out both horizontal and vertical polarizations and looking at the images back, we can tell you if it's a lot of light drizzle or a few drops that are really mammoth. And then we can also tell you if it's sleet or snow by the parameters of it and the intensity of the feedback. There's a lot of different things going on here. And now, let me drop a second. Now we really get into some intense computer manipulation and so forth. You know how we're looking at Photoshop that can go and analyze things, and we can go and play around with things and manipulate them and measure things and check all kinds of parameters and stuff like that. Well, they're doing that with the radar images too. Just because you see a particular image right now doesn't mean that that's the whole story. The computer keeps track of all the information up to that particular point and generates a trend. And then from that, it can predict what's going to happen. And you can generate a much better picture from the computer analysis of the previous history. And now you're used to seeing on the weather maps and the TV stations that particular polar plot where the band is, or the sweep is rotating around the antenna. Well, that's not the whole story. They can also manipulate the angle that the beam is going out with respect to the horizon. And they can also stop the beam and do a vertical sweep. So a particular storm cell, they've identified the center of the cell, they can do a vertical scan and do a profile, a cross-sectional area of that particular storm cell and see how high it goes up and what's up there as far as rain, snow, whatever. And then, like you were saying, they can look at the particular Doppler signals coming back and look at wind shift and wind shear and so forth and so on. The computer has opened up so many things. Let me drop again. And again, one more thing. When we're talking about 31.4 hertz Doppler shift per mile an hour at 10 gigahertz, that is a very small percentage of deviation in frequency of the transmit frequency. Very difficult to detect. But now if you go into a different mode and you start to check the phase difference between the transmit and the received signal, now you have a much more accurate resolution and you can dig out finer details because you're not looking at a frequency change, you're looking at a phase change, which gives you a much better indication. And that is measured with other parameters and so forth, gives you a much more accurate presentation of what's actually going on there. So with that, let me throw it back to Neil. I'm probably way over talking by now.
No, Jim, it's fine. This is great stuff because you've surpassed where my knowledge falls to the ground, obviously. And when I do these nets, and even when I do my makers class on Wednesdays for LICW, one of the things I always tell people is, I'm not an expert on this subject. I just love talking on the radio or in front of a camera or in front of a group. I like pulling all the information together or finding the right people to talk about it. And for a subject like this, Jim, you are definitely the right person. I think we could probably do a whole organized presentation for a group between you and Kenny on how weather works and its relation to ham radio. This is good stuff, and it really does make a lot more sense now. I mention this guy every now and then because he did a Sunday night technology net that I discovered when I first got my ham license, and that's Dick Nadel. He ran this net on Sunday nights out of Long Island for many, 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 many years. He passed away a few years ago. More than once, I heard Dick give a discussion on what radio waves do when they hit a raindrop, and how they react to rain. And it was always interesting. And, what kind of effect does it have? And it's different at different frequencies. It's different in different volumes of rain. And I'm not going to get into it because I don't even remember most of it. It was always fascinating when I heard it. And I'm sorry I didn't take notes, but I hope that helps a little bit. Let me throw it back to Jim for a couple more words, and then we'll see if there's anybody else out there who wants to throw their call sign into the ring tonight. But Jim, a couple more words, and then maybe throw it to Kenny real quick before I take it back.
Yeah, okay. Basically, I threw a lot of highly technical stuff out there tonight, and if anybody has any questions, wants something clarified or whatever, feel free to speak up. That's what we're here for. It's if you got the question about it, somebody else probably does too. So ask the question, and we'll try and clarify things. Because I have been doing this stuff for years, and it's second nature to me, but it's new to you. So I'm sure there's probably quite a few questions out there. And with that, Kenny, a few words from you, K2BHM.
No, look, what do they say are the things that that we face every day? What is it? Death, taxes, and weather. And weather, can be very serious, but our everyday lives really depend on weather. Whether we're doing outside chores, gardening, cleaning, dealing with issues of flooded basements, leaky roofs, even just getting your car washed. How frustrating is it? You think the weather's going to be beautiful for the next 5 days. You go ahead and get your car washed, and then literally that afternoon it starts raining and your car is filthy again. Weather is just so important, but it's also an awful lot of fun to be involved in it and to learn about it. And there are some great apps and great sites that you can go to. There is one site that I'm going to send to everybody on this net tonight. It is the site that includes all of the weather models that any forecaster on this planet uses to determine the weather. So you can actually look at these models and know what they're talking about if you're watching a weather forecast. It's very, very cool. So I will send you the link with my username and password. Just don't pass it on to other people. Just keep it to the folks on this net tonight. And if you have any questions, I'd be happy to help out. But really great information here tonight, Jim, and thank you. And anybody has any questions for me, I'm more the teacher of the layman stuff. Anything you want to know about weather predictions and the reading of the models and understanding the data and all of that, I'm very happy to help. But all the technical stuff, Jim is the man. And thank you again, Jim. I've learned an awful lot. Back to you, Neil, W2NDG from K2KRP.
Thanks, Kenny. And thank you, Jim. And thank you, Kenny, again, for all the great information tonight. This is W2NDG on the OMARC Sunday Night Science and Technology Net. One really quick question for Jim, then I'm going to see if there's anyone else who wants to check in. Jim, are you familiar with the wind maps like Ventusky.com?
No, not really. Enlighten me.
If you're sitting in front of the computer, Ventusky, V-E-N-T, like vent and U-S-K-Y, Ventusky.com. It's a live map of the wind currents. And I'm wondering if it's produced from a radar source. Kenny, you might know more about this than I do.
Can you repeat it, Neil? I just stepped away for a quick second. Just repeat the question.
Whether you are familiar with Ventusky, the wind map that they publish on the internet, and I know some other sites get into this, but Ventusky.com, and it's a live wind map of the Earth, basically. And I was wondering if that's sourced in radar.
I don't know. I am familiar with it. I don't regularly look at that site, but I am, I've heard of it, but no, I don't have an answer to that. Sorry.
All right, no, that's fine. And what's neat is for anybody who wants to check this out, again, it's Ventusky.com, Ventusky, or I'm probably pronouncing it wrong because the SKI is highlighted, so it's probably Ventu Sky, Ventu SKY, Ventu Sky. It shows the wind currents because it knows where I am. It's centering on the Hudson Valley basically and showing as far west as Nebraska and the Dakotas and out into the ocean to the east. But you can layer other things on it. You can layer radar images, clouds, wind speed information, all sorts of things. And you can see how the wind motion on the Earth is affecting things, why the storms are moving in the directions they are. It's pretty cool. I'll just throw it back to Jim and see if he had a chance to look at this.
Yeah, thanks, Neil, K2BHM. Yeah, this is cool. And from what I'm seeing, I don't see anything that indicates the origin, but I would assume that it is radar because that's one of the things that was mentioned in weather radar is that, yes, you see Doppler motion predicting or showing the motion of the rain and the clouds, but in the absence of them, you can up the gain and so forth and track particles in the air and get your air currents from that. So that's how you determine wind direction, velocity, and so forth and so on in the lack of precipitation.
Well, stuff gets so cool. Anybody else who's looking at this while we're talking about it, if you zoom way out so you can see everything, you'll notice the winds spiraling around a storm in the Atlantic called Wanda. They have a little symbol there. Cool stuff. Is there anybody else who would like to check in tonight on the OMARC Sunday Night Science and Technology Night? Come now with call sign, first name, and location. All right, that's fine. Let's do a really quick wrap-up round here. I'm not sure if everybody's still awake, but we'll run through really quick and just final comments, final questions, and then we can address questions kind of like open session after the round. Mike, KC2UVP, anything else tonight? Mike, you still there? All right, no Mike. John, K9JPT, are you still with us?
Roger.
Any final comments, questions, or information?
No, just very enlightening hearing about how all this stuff comes together, and I like the insight now that I have in all this. Over.
No, it is cool. It's I always describe myself as I've said many times on here. I am an information addict. I need to know, and it's stuff like this, that helps so much. I like to know how things work. It's one of my old coffee table books, by the way. The Way Things Work. Love that book. Cool. And thanks, John, for the topic seed, we'll call it. Matt, KB2GGF, have you ordered your Raspberry Pi and 3D printer yet?
No, not quite yet. I'm going to move slowly and carefully. But yeah, I am interested in setting something up. Question I do have, which is a very basic meat and potatoes question. If I set up a rudimentary system where, say, I collect temperature, barometric pressure, and humidity information, can I post that data to Weather Underground? And can I do that via my PC? So do like a very rudimentary beginning. I wonder if that's possible.
I'm pretty sure it is. Well, no, I'm positive that it is, but you would have to know the format of that data stream. Weather Underground works with APIs, and that's how you integrate devices into their system for both getting data to them and receiving data from them. So it might require borrowing somebody's open source Python code, let's say, and just making some edits to it. And I know anytime I mention stuff like this, everybody shakes in their boots and says, but I don't know how to do this. I'm not a programmer. Trust me, when you see the code, you'll understand what it's doing. It'll make sense, and you'll find the sections that you need to edit. It's really a lot easier than it all sounds. And we have plenty of people around who can assist with stuff like that. Jim, I kind of have that right. You've looked at the bare information coming out of our weather stations. It's probably not that hard to get that up to Weather Underground.
Okay, I think I'll begin with something like that. I, of course, would like to get wind speed and rainfall amounts and wind speed and direction, but that could be future. I just want to get started and get my feet wet with it and see if I like it.
Oh, cool stuff. And I'd be really curious as to how it all comes together. There's also the ability to report that weather through the APRS system. And we have people here who are a lot more familiar with that than I am. So that's also another direction to look in. All right. Thanks, Matt. Thanks for checking in tonight. Tom, N2FCC, are you still with us? And any final comments?
And to SDC, I've been in and out. I have no final comments. Interesting topic, though. And to SDC, back to now.
All right. Coffee Man, Jim, KD2VAH. I know what to get you for Christmas this year. If we're going to have a lot more rain, I'm going to get you a coffee maker just for your basement. Any final comments? Are you still with us?
That would be an absolute welcome gift. No, I've been with you all night. I gotta say, I originally started out with getting the outside weather thing, whatever, so I could be part of the net. I mean, be part of the group. And I have found it to be enlightening for myself. It's nice to come down and I can look at it. I can say, oh, the wind's kicking up. What the heck's going on? The rain, of course, but I've never noticed before during storms how much rain we got. How do you judge that? I mean, it rained all day. Now I know pretty much how much rain, because we've all seen it rain all day, and it might have been a quarter of an inch. So I mean, I've learned that. The barometer stuff, I'm still learning, and I don't think I need to know about the light or the UVI, but I do like the idea of the wind and the rain thing. The forecast, 90% of the time, they're not always correct. I believe they're going by that barometer. And I have no idea on how to read that either, but I'm learning that that's an important feature. Anyway, great net tonight, guys. Anyway, back to net.
Thanks, Jim. I appreciate it. And we try. It's good to have Jim back so we can get into some of these deeper, longer subjects. Kenny, K2KRP. And once again, thank you. Thank you for coming tonight and helping us with this topic. And thank you for the original push in this direction, which really got a lot of us involved. Any final comments tonight, Kenny?
No, glad I got home in time. and it was very interesting. I learned an awful lot, and I think the WeatherNet is great. I think we need to probably have some refreshers and make sure everybody's equipment's up and running. Matt, just FYI, AccuRite has a very good sale going on right now. It ends on Tuesday. If you want to get a simple weather station, and as Neil mentioned, if you don't want to get a weather station now, you can still gather whatever data you have, and you can send it to the Weather Underground. I will send you links on how you can get your data into the Weather Underground. You will have to sign up for an account. It's free, but you do need to set up a username and password for Weather Underground. And once you do that, which again is free, you can then gather your information and send it off to them. And I will send you links on how you can easily do that. Anyway, thanks everyone. This was great. Back to you, Neil, K2KRP.
Thanks, Kenny. And thank you again. Paul, N3EYQ, you still with us? Any final comments?
Oh, darn, my HT turned off. I've been listening on the other radio. Did a little research on the internet. A little bit of noise in the background. Radar P3. I back in 1981, I got a chance to play with some radar on a Navy P3 aircraft. You know, aiming at the ocean, aiming at the sky, see what the it was totally amazing. I really missed my calling on this thing in the Navy. I should have been an AW or something like that. But that's how that goes. And Kenny, you know, I've been doing some looking around, and I didn't realize how influential you've been in the news business. But I'm glad you had a good career over the years. Other than that, N3UIQ, back to that.
Thanks, Paul. And just for anybody who doesn't have a station yet, people listening tonight, people watching after the fact on the YouTube stream, what Kenny was talking about, the sale, I'm looking right now, the one that I purchased, the Iris 5-in-1, is currently on sale for $164.99 at AccuRite. And mine has been flawless pretty much since I put it out there. So, good stuff. Jim, a wrap up, and then we'll close things up. K2BHM, come now.
Thanks, Neil. Yep. No, I'm happy that Kenny got us into this. My Iris has been working like working perfectly for what's it been, a year or so now? And we've got the station here showing live data, and I was able to keep an eye on things when I was down in St. Martin. It's something that you can connect to around the world and see how much rain you're getting home, and everybody got a kick out of it. And yeah, there is a program for the Raspberry Pi. I was looking around, but I don't see it. But there is a program that will work with your SDR and look at data on 300 megs, which is where the AccuRite transmits, as well as several other things. So you can see the decoded data from your wind station or your outside 5-in-1 station, my lightning tower, the power meter, several other different things. There's lots of different things. Even your remotes for your car is transmitted at 300 megs, so you can push the button to open up your car and see that on the Raspberry Pi. So it's interesting, and it's out there. I don't know. I don't think it would be usable to transmit data back to Weather Underground or something like that. I think they need their own format, but it's there if you want to look at it and play with it. So I'll have to see if I can find that again. It's around here somewhere. Anyhow, enjoy it tonight. Very interesting. Some very good information going back and forth, and I hope everybody enjoyed it. Back to you, K2BHM.
Thanks, Jim, and thanks for your input and expertise as always. All right, let's wrap things up. Once again, this has been the OMARC Sunday Night Science and Technology Net. We meet here every Sunday night at 8 p.m. on the repeater of the Overlook Mountain Amateur Radio Club on 146.805 megahertz. You do not need to be a member of the OMARC Club to be participating in these nets. However, we do encourage you to check us out. We're a friendly club, and you can find us online at omarcclub.org. That's OMARC, OMARC omarcclub.org. There are other nets hosted on this frequency as well. Every morning at 8:35 a.m., we host the 8:35 on the 805, a casual roundtable style net, not a directed net, started during the COVID pandemic for hams to keep in touch. As Paul frequently says, hams are social creatures, and it allowed us a way to stay in touch and make sure everybody was okay. Some of us were not used to being locked in our homes for a period of time, and it was good to have that connection and people to talk to and lean on a little bit at times. Also, every day at 6:30 p.m., similar net, the 6:30 p.m. check-in net is more of a directed net, but still casual. We all check in and talk about how our days went and what we're planning on doing the next day. And if we need any assistance with anything, the community is always there for us. Every Thursday at 8 p.m., Dave, K2JLV, hosts the Thursday Night Technical Net, a more ham radio oriented net, although sometimes it does dive into computers and similar topics, but usually ham radio related. Dave takes check-ins, sees if there's a topic either related to a question or a troubleshooting problem on the first round. If a topic does not present itself, Dave spins the topic wheel and picks one for us. Always a fun net. And finally, every Tuesday at 8 p.m. is the Ulster and Northern Duchess Readiness Net, or UnderNet, and that is a group of hams practicing getting ready to communicate using different methods in the event of an emergency. Right now, they have been demonstrating and playing around with the sending of digital signals over FM when there is no cellular network or internet to deal with. Just a little proof of concept that shows that if you need to send something that can't be described with words, you can still take a picture of it or take a picture of text and send it over the radio. Really cool stuff. And of course, the repeater has to get the last word in there. I am again W2NDG, Neil in Highland, New York. This has been the OMARC Sunday Night Science and Technology Net. We thank you for checking in. We thank you for watching on YouTube. I'm going to end the stream now. Everybody have a really good night. We'll catch you again here next Sunday, and some of you